Hello everyone, this is Mr. McMillan, and today I'm going to be going through the instructional video for the midpoint distance and slope formulas. And in it, as the title says, we're going to be covering these formulas, but also we're going to be covering how to find endpoints. And the slope formula is not just the slope formula, it's also finding it from equations and from graphs. So for the midpoint formula, if we know the coordinates of 2 points in the coordinate plane, and we label these as A, x1, y1, and B as x2, y2, that are endpoints of a line segment, then we can find the midpoint of the line segment. So let's evaluate the following diagram to see why. So as we talked about with midpoints, a midpoint is the halfway distance in a line segment, right? So it's your halfway point, it's the middle. Now, if you remember when you talked about averages and median and mode and all that stuff, when you talked about that in statistics, you know that that was considered to be the middle of the data set. And one in particular that you used is called the mean. And that was where you added all the numbers together that you had and divided by the number that you had. So you took the average. We're going to be doing the same thing in essence here to find our midpoint. So we have 2 points here, A, which is x1, y1, and B, which is x2, y2. And we can see that if we extend these here, we can see that if I can draw a straight line, that these are where the points are located. Okay. Now, in order to find our midpoint, we're basically taking the average of the coordinates, but we do it piece by piece. So we do the x's separately, and we do the y's separately. So the midpoint here, the x coordinate is found by taking the average of x1 and x2. And what we do there is we take x1 plus x2 and divide by 2. So that's our x coordinate for the midpoint. And likewise, with the midpoint of the y's, we take the average of y1 and y2. So we take y1 plus y2 divided by 2. And so that is our, that would be the coordinates of our midpoint. So essentially what we're doing is using 2 different one-dimensional midpoint formulas for the coordinates, which combine to form an ordered pair. This ordered pair is the midpoint of the line segment. So formally stated, the midpoint formula, the coordinates of the midpoint of a segment are the averages of the x coordinates and the y coordinates of the endpoints. The midpoint of the segment joining A, x1, y1, and B, x2, y2 is, and this is your formula, M, which is your midpoint, equals, parentheses, x1 plus x2 over 2, comma, y1 plus y2 over 2, in parentheses. So your midpoint is a point. So when you figure out what x and y are, you need to put your parentheses as well. So let's look at some example problems here. So number 1, it says to find the midpoint of GH. Now GH is a line segment on this line, or on this graph, excuse me. So we need to determine the coordinates of G and H before we do our midpoint formula. And so when we do this, we look at the coordinates for G. Remember, you go left and right first. So we have to go left 4, so that's -4. And then we go up 5 to get to G. Then our next thing here, we need H. So we go right 1, down 2, so that's 1, -2. And now we're going to label our points with x1, y1, x2, y2. So -4 is x1, 5 is y1, x2 is 1, and y2 is -2. You could do it the opposite way. This point being x2, y2, this one being x1, y1, it's not going to change your result. So now our midpoint formula, m equals x1 plus x2 over 2. So our x's are -4 and 1. So we're going to take -4 plus 1 and then divide by 2, comma, and then we do our y's the same way. So 5 plus -2 over 2. -4 plus 1 gives us -3 over 2. 5 plus -2 gives us +3 over 2. Usually you'll see if this can be simplified, the fractions can be simplified. In this case, you have -3/2 and 3/2, which do not simplify. You may also see the answer in decimal notation. So you might have -1.5, comma 1.5 as your midpoint. The important thing here is that if your fractions can be simplified, simplify them. So for example, if you had 8 over 2 here, 8 over 2 divides evenly, so that would be 4 instead. Okay, so make sure you do those simplifications if you can. All right, so try number 2 and 3 and come and check your answers along with the video. So pause it and come back. All right, so let's look at number 2. Find the midpoint of the line segment with the given endpoints. So it gives us the endpoints are -2, 5 and 6, -5. So we're going to label our x1, y1, x2, y2. x2, y2. Our midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. Plugging our values in, we get -2 plus 6 over 2. Then we have 5 plus -5 over 2. Simplifying, we get -2 plus 6, which is 4 over 2. Then we have 5 plus -5, which is 0 over 2. Check to see if your fractions can be simplified, and you get 4 over 2, which is just 2. And you get 0 over 2, which is 0. So your answer for this one would be 2, 0. All right, so number 3, find the midpoint of xy given x is 0, -8, and y is -3, 13. So again, you're looking for your midpoint, so you're going to be using your midpoint formula. Your x1, y1, x2, y2 for your midpoint. So if you plug those in, remember your x coordinate always comes first. So you've got 0 plus -3 over 2. And then for your other one, you have -8 plus 13 over 2. Make sure you pay attention to your signs. So 0 plus -3 is -3 over 2. And then you get -8 plus 13, which is 5 divided by 2. And you'll notice that neither of these can be simplified. And if you want to write them out in decimal notation, that would be -1.5, 2.5. So either one of those would be correct for that problem. All right, so the next formula we're going to talk about is basically the endpoint formula. And while it doesn't really have a formula, it's based on the midpoint formula, okay? So at times we will be asked to find the endpoint of a line segment rather than the midpoint of the line segment. When asked this, we will be given one endpoint and the midpoint. Let's look at the process for finding the other endpoint. To find the endpoints, we will be using the midpoint formula basically in reverse. Okay. So these first 4 steps, this is how we would do it algebraically. And then the shortcut method is what, you know, we can do just to get through it quicker. So for the algebraic method, the first thing you do is set up the equation based on the midpoint formula. So your midpoint formula is m. Now your midpoint is given by the coordinates x sub m, comma y sub m. And your formula is x1 plus x2 over 2, comma y1 plus y2 over 2. The next step is to set up 2 separate equations. Now, normally you'll have like values in here, and you want to know what x2 and y2 are. And here we're just going to keep them as the xm, yms, and all that stuff. But just know those will be numbers plugged in there. So we set up 2 separate equations. So we set up one for each coordinate. So xm is in the first spot. So we set it equal to the first spot there. So x sub m equals x1 plus x2 over 2. And then we do the same thing for the y's. Y sub m equals y sub 1 plus y sub 2 over 2. Then we want to solve each equation separately for the missing coordinates. In the general case, this will be x2, y2. So here, we're solving for x2. So we want to get rid of that 2. It's being divided on this side, so to get rid of it, we need to multiply both sides by 2. And we get 2 times x sub m is equal to x sub 1 plus x sub 2. We want to get the x2 by itself, so we have to subtract x1 on both sides. And so we get 2x sub m minus x sub 1 is equal to x2. Likewise, you would get the same thing here, just with y sub m instead, and y sub 1. Now, that probably just looks like a jumble of symbols and everything else, and you would be right. You would be right that it is indeed just a jumble of symbols. But you have to remember that these xm, ym, x1, and y1 would be numbers. So this is, I show you this just to, you know, kind of get you thinking about it. And then here's the shortcut method. This is the method we typically use to solve the problems. So step 1, we want to list the given midpoint. So the midpoint is given by x sub m, comma, y sub m. Our second step is to multiply the midpoint by 2. So we're going to multiply both of the coordinates by 2. So times 2 times 2. And so we get 2x sub m, comma, 2y sub m. Now I want to point out something here. If you look, this is the first step we did here as well once we set up our equation. So we multiply by 2 here. We do the same exact thing here. We're going to multiply by 2. Okay, then it says subtract the given endpoint. Make sure to line up the coordinates correctly. So we're going to subtract x sub 1 from the x's and subtract y sub 1 from the y. And when you do that, you end up getting the coordinate 2x sub m minus x sub 1, comma, 2y sub m minus y sub 1, which is the same thing we ended up with here. And if you're still going, I don't know about this, Mr. Millen, we're going to be doing some examples that show you how this works with numbers involved. And then I'll show you how you can check your answer. Okay? So let's look at some example problems. We're going to do numbers 1 and 3 together, and then you can try numbers 2 and 4 on your own. So number 1 says R is the midpoint of xt. Given that x is -8, -5, and r is 3, -7, find t. So the first thing you want to do is identify the midpoint and endpoint if that's what you're given. So it says R is the midpoint, and we see that we have a midpoint here. So we say that our midpoint is 3, -7, and our endpoint would be x, which is given as -8, -5. So our first step is to list the midpoint. So we're going to write out 3, -7. Then we're going to multiply it by 2. And we get 3 times 2, which is 6. -7 times 2, which is -14. And then we're going to subtract the given endpoint. So in this case, we're going to subtract -8 from 6. And we're going to subtract -5 from -14. Now remember, you have to be careful about your signs. You are subtracting a negative in this case, so this becomes a positive. So you get 6 plus 8. So 6 plus 8 is 14. And then -14 plus 5 is -9. So your endpoint would be 14, -9. Now the way you can check that, you've got 14, -9 here. So you know it's an endpoint, so you can use your other endpoint and see if you get the midpoint back. So 14 plus -8 is 6, divided by 2 is 3. The x checks out. Now we do -9 plus -5, which is -14, divided by 2 is indeed -7, so we did this correctly. All right, number 3, it says given one endpoint of a line segment is 2, 0, and the midpoint is -3, -14, find the other endpoint. So we're going to list our midpoint first, and the midpoint is -3, -14. Our second step is to multiply by 2. So we get -6, -28. And then we're going to subtract our endpoint, which is 2, 0. So we're going to subtract 2, subtract 0. And when you do that, -6 minus 2 gives you -8. And -28 minus 0 gives you -28. And again, if you would like to check that, you can check that using your endpoints and using the midpoint formula to see if you get your midpoint formula back. All right, so I want you to try numbers 2 and 4 on your own. So pause the video, then come back and check and see if you got them right. All right, so let's look at number 2. E is the midpoint of GH. Given H is 0, -4, and E is 2, -4, find G. So you're going to list your midpoint, which is said to be E, which is 2, -4. Then you're going to multiply both of them by 2, and you get 4, -8. And then you subtract your endpoint. So you're going to subtract 0 and subtract -4. So 4 minus 0 just gives you 4. -8 minus -4 becomes -8 plus 4. And -8 plus 4 is -4. So that is what G is. And number 4, if the coordinates of C are 4, 2, and the midpoint of CD is -7, 5, then what are the coordinates of D? So we list our midpoint, which is -7, 5, multiply by 2, and we get -14, 10. And then we subtract our endpoint. So we're going to subtract 4 and subtract 2. One of the biggest mistakes I see is people adding the endpoint instead. You always need to make sure you subtract. So even if that's negative, subtract the negative and then change it to a positive when you need to. So you get -14 minus 4, which is -18, and 10 minus 2, which is 8. All right, so we're going to move on to our next formula, and our next formula is the distance formula. Okay. And, you know, we can derive this using the Pythagorean theorem. We're not going to worry about that too much. I'm just going to give you the distance formula, considering this is a mostly review over what you did in algebra over this. So if you look here, the distance formula is said to be the distance between 2 points in the coordinate plane can be found by taking the square root of the sum of the square differences of the x and y values of the coordinates. So symbolically, our formula is d equals the square root, parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. If you're interested in seeing the distance formula derived, you can always look up a video for that. But I want to focus more on the formula and how to use it. So let's look at some examples. We're going to do 1 and 3 together, and then you can do 2 and 4 on your own. So number 1, it says, what is the length of CD given C 9, 4 and D 1, negative 2? So this is just like the midpoint formula where you're going to label your x1, y1, x2, y2. Okay? So you've got 9, 4, that'll be our x1 and y1, and D will be x2 and y2. So our distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And plugging those in, x2 is 1 minus x1, which is 9 squared, plus then negative 2 minus 4 squared, because that's our y2 minus y1. And now that we have this, go ahead, jump into Desmos and type that straight into your calculator. Type it in exactly as it's written down. Okay? So you're going to put the square root and then parentheses 1 minus 9 squared plus, and then you're going to have negative 2 minus 4 squared. And so you end up getting 10 for this answer. So your distance, your length of CD in this case would be 10. Okay. The calculator's a tool. Use it. All right. All right, so let's look at number 3. Number 3 says to find RS. Now, if you see this where it just says find RS or QT or whatever and doesn't have a line segment over it, what you need to do is find the distance, okay? If it wants you to find the midpoint, it'll tell you, find the midpoint. If it wants you to find the slope, it'll tell you, find the slope. If it wants you to find an end point, it'll tell you, find the end point. But here, it just says find RS, so that means the distance. Okay, so find the length of RS. So we're given a graph here, so we need the coordinates of R and S. The coordinates of R are at negative 3, 4. And the coordinates of S are at 3, negative 2. Okay. So we're going to label our x1 and y1 and x2 and y2, and then use our distance formula. So the distance formula, we're going to do the square root. And in our first set of parentheses, we have x2 minus x1. So that's 3 minus negative 3. And when you do that, it changes that to a positive. So it becomes 3 plus 3 squared plus, and then you have y2 minus y1, which would be negative 2 minus 4 squared. Now that we have it in the formula, we can go into Desmos and type that in. So square root of 3 plus 3 squared plus negative 2 minus 4 squared. And that gives you, rounded to the nearest tenth, that D is approximately 8.5. Okay. So that would be your answer. Now, sometimes questions will ask you for an exact answer if it's multiple choice. And what you need to do is check each answer choice and see which one matches up with your decimal. So I'm going to have you guys try numbers 2 and 4 on your own if you want. So pause the video, try those, and then come back and see how those are worked out. So let's look at number 2. It says find FG given F is -5, -5, and G is -5, 7. So we're going to have X1, Y1 be our F and G be X2, Y2. So our distance formula is the square root of X2 minus X1 squared plus Y2 minus Y1 squared. So D is equal to the square root of -5 minus -5 squared. The negative becomes a positive because you're subtracting it. Then plus Y2 minus Y1 squared, so that would be 7 minus -5, so that would be 7 plus 5 squared. Now you can type that in the calculator. When you type this in the calculator, you're going to end up with the square root of 144, which is 12. Okay, so you should end up with D equals 12 there. Then number 4, what is the distance between X and Y? So X is at coordinates -4, -1, and Y is at coordinates 1, -5. So then we just plug it into our distance formula. So we have D equals the square root of X2 minus Y, or X2 minus X1. So we have 1 minus -4, which is 1 plus 4 squared, plus, and Y2 minus Y1, which is -5 plus 1 squared. And when we plug that in the calculator, we get 1 plus 4 squared plus -5 plus 1 squared, which is 6.4. Okay, so 6.4. All right, and the last thing in this video that we're going to cover is slope, and we're going to cover 3 different things for slope. So the slope of a line, as you guys know from Algebra 1, is the ratio of the vertical rise to the horizontal run between any 2 points on the line. And we say that the slope is how steep a line is. So to find the rise and the run, you need to find the change in Y and the change in X. So when you do it using the points themselves, you subtract them because that's the change, right? When you give a cashier money for your order, whatever they ring you up for, and they give you back change, they subtracted what you owed from the amount you gave them, and that is what you got. So they gave you the difference. Or if you're using the graph, you can find your rise and run by counting the spaces. Okay, so if a line passes through the points A, X1, comma, Y1, and B, X2, comma, Y2, then we can say that the slope of the line, graphically, remember we use M, lowercase m is the slope, is rise over run, which is the change in Y over the change in X. algebraically, we can say that this is equal to y2 minus y1 over x2 minus x1. And if we draw that on the diagram here, we can see, let's see here. We can see the difference between here is the rise, and this is your run. And this point here is x1 comma y2. So in order to find the run, you would have to take your x's. So you would take x2 minus x1, and your rise would be equal to y2 minus y1. And that's how we get those equations. So this is the algebraic way. This is if you're given 2 points. And this is your graphical way where you count the spaces to find your rise over your run. Don't forget your signs. If you count up, you go positive. If you count down, that's negative. If you go right, that's positive for the x's. And if you go left, that's negative. Okay. So just formally stated, given 2 points, the slope m is equal to m equals y2 minus y1 over x2 minus x1, which is the rise over the run. So, as you guys know from Algebra 1, your slope of a line can either be positive, negative, 0, or undefined. And so if we look at these graphs below, let's say we had these 2 points here. Now, I typically always start from the lower one. I know some people start from the leftmost one. It's whichever way. If you start from the leftmost one here and go to your other point here, you're going to be going up first, and then you're going to be going to the right. So that means that you have a positive rise and a positive run, because you're going up and then to the right. So that means that your rise over run, your slope, is equal to a positive over a positive, which means that this slope is positive. So if you remember, it's up and to the left, or sorry, up and to the right or down and to the left, whichever way, okay? Likewise, if you have your points here, you're going down first if you're starting at the leftmost point, and then you're going right. So you have a negative run this time, and a negative rise and a positive run. So your rise over run ends up being negative over positive. And if you have a negative divided by a positive, that means it's a negative slope. The two special cases are the 0 and undefined slope. If you have a horizontal line like this, that has a slope of 0. Okay, that has a slope of 0. Anytime you have y equals just a number, that gives you that slope. Okay, y equals a number gives you m equals 0. And then for undefined, you can see that this is a vertical line. So anytime you have just a straight vertical line, your slope is undefined. And that has the equation x equals a number. Okay? So just keep that in mind as you go along. The reason this is undefined is because this has no run, and you would end up dividing by 0. So your rise over run would be equal to, you know, whatever over 0. And so you can't divide by 0. So that's why it's undefined. Whereas this one would be your rise over run. You have no rise because you're not going up or down. So 0 over whatever number, and 0 over any number other than 0 is just 0. Okay? All right. And then the last thing here, we have a slope-intercept form. And slope-intercept form is a linear equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. So if it asks you for the slope of an equation and you get something that's y equals mx plus b, there's something in front of x, the number in front of x is your slope. So let's look at some example problems. So number 1, x equals -8. So this is of the form x equals a number. So right off the bat, we know this is an undefined slope. And I'll graph this to show you. So we have x equals -8. And as you see there, x equals -8 is just a vertical line straight up and down. So it has an undefined slope. Number 2, y equals 4x minus 9. This is an equation in y-intercept form, or in slope-intercept form, excuse me. So the number in front of x is m. So that means that our slope is equal to 4 in this case. Number 3, y equals -2/3 x. Even though it doesn't have a b at the end of it, it's assumed to be 0. So we look at the number in front of x, which is our slope. So in this case, m is equal to -2/3. And finally, number 4, y equals 2. And y equals 2 is of the form y equals a number, which means that our slope is automatically 0. And we can see that when we graph this, y equals 2. Oops. Y equals 2. And we see that it's a horizontal line that has no rise, and, you know, it always has a run. So it's horizontal, which means it is a slope of 0. All right, number 5. Number 5, this time it gives us a graph. So since it gives us a graph, we can just use our rise over run. So we start from L in this case, and we go up 1, 2, 3, 4. So we go up 4, and to the right 1, 2, 3, 4, 5. So that's a positive run because we're going right. So m is equal to rise over run. Our rise was +4, and our run was 5. So our slope is 4/5. And then number 6. Number 6, we have a and m. If you want to try and find that slope real quick, go ahead. If we start from our leftmost point, we're going to go down 1, 2, 3, 4, 5, 6, 7. So we have a rise of -7. And then we're going to go right 1, 2, 3, 4, 5, 6, 7, which is a positive run. So our slope is rise over run. So we get m equals the rise of -7 over the run of +7. -7 divided by 7 ends up giving you -1. So your slope for this line is -1. All right. Next up, what it wants us to do for the next 4 is find the slope of the line that passes through the given pair of points. So this is where we need to use the slope formula. So let's look at this. So number 7, our slope formula, remember, is m equals y2 minus y1 over x2 minus x1. So if we do that after we've labeled x1, y1, and x2, y2, we do y2 minus y1, which is negative 20 minus 11, over x2 minus x1, which gives us negative 18 minus negative 2. And when we subtract that negative 2, it becomes a positive 2. Simplifying this, we get negative 20 minus 11 is negative 31. Negative 18 plus 2 is negative 16. We have a negative on both the top and the bottom. The two things, the two negatives cancel, and we get 31 over 16. And just in case you guys didn't know, you can simplify fractions in Desmos. So if you go into Desmos and type in your fraction, and it gives you a decimal, like here, 31 over 16 give you 1.9375. If you look to the left side here, you'll see a circle with a fraction bar in it. Click that, and it will change that decimal to the fraction in simplest form. So this one does not simplify, so we just leave it as our slope being 31 over 16. Okay. All right, let's look at number 8. So number 8, our x1, y1, x2, y2. We're looking for the slope, so we're going to take m equals y2 minus y1 over x2 minus x1. So y2 minus y1 gives us negative 14 minus 12. x2 minus x1 gives us 6 minus 6. Negative 14 minus 12 is negative 26 divided by 0. You cannot divide by 0, so this would have an undefined slope. If the 0 were on top instead, you could do 0 over whatever, and that would just give you 0. So try number 9 and 10 on your own using the slope formula and check back in to see how you did. All right, so number 9, we have 17, negative 13, and 1, 3. Our slope formula is y2 minus y1 over x2 minus x1. y2 minus y1 will give us 3 minus negative 13, which would be 3 plus 13. And then we do 1 minus 17 for our x2 minus x1. So we get 3 plus 13 is 16. 1 minus 17 is negative 16. 16 over negative 16 gives us negative 1. And finally, number 10, our slope, y2 minus y1 over x2 minus x1. So y2 minus y1 gives us 7 minus 7 over x2 minus x1 gives us negative 2 minus 8. 7 minus 7 is 0. Negative 2 minus 8 is negative 10. 0 divided by negative 10 is 0. So our slope is 0. And that does it for this instructional video, guys. I hope this helped. If you do have questions, we're going to be working on using these formulas for a little bit. There is a worksheet on the Google Classroom page. So if you go to Google Classroom page and you get the practice here, it is a little bit, it's got 30 questions. We'll be taking some time early in the class to go over this, to work on it a little bit and then go over it. So the first 8 wants you to find the midpoint. The next 4 wants you to find the end point. The next 6 wants you to find the distance between the pair of points or the graph. 19 through 24 wants you to find the slope using equations. 25 and 26 want you to find the slope using graphs. and 27 through 30 want you to find the slope using the slope formula. Okay? If you have any questions about this material, please make sure that you email me, and I'll help you out. Otherwise, I'll see you in the Zoom next time, or I'll see you in the next video. Thanks, guys.